All right, guys, we're going to talk about rational functions today. A rational function is a function that is the quotient of two polynomials. And when you look at the actual look of the function, it looks like a fraction, and the numerator and denominator have polynomials in it. So, for example, here's a rational function that has a polynomial of 2x in the numerator and x minus 2 in the denominator. Here's another one that has 3x cubed in the numerator and x squared minus 2x minus 8 in the denominator. It can have just one term, 3 terms, 2 terms, doesn't matter as long as there's a polynomial on the top and the bottom. It could even just have a number in the numerator or denominator. Still makes it a fraction. Evaluating rational functions is just like we've done in the past. If you have a function like 2 plus x over x squared minus 5, and you're evaluating it at f of 2, all you're doing is plugging in 2 every time you see an x. So here's our function, 2 plus x over x squared minus 5. We're going to take those x's, take them out of there, and replace it with the number 2. So now, if you're solving this, we're looking at 2 plus 2 in the numerator. 2 squared is 4 minus 5 in the denominator. 4 divided by negative 1 is negative 4. If you go in reverse, if you have a function like g of x equals x squared plus x minus 8, all divided by x plus 2, it's still a rational function. This time I want to know what x is. When I give you the value of the function is 2. So you're plugging in 2 for the value of the function, and you're solving for the x. So this time, it's equal to 2, not plugging in 2. So now you're trying to get x by itself. If you multiply both sides by x plus 2, you get 2 times the quantity of x plus 2 equals the numerator of the right side. Distribute, and you get 2x plus 4 on the left side. Still have to get x by itself. You notice it's a quadratic, so you should be getting everything on one side equal to 0. So subtract 2x and you get negative x. Subtract 4 and you get negative 12. That is factorable. Your factors are x minus 4 times x plus 3. So you get two answers. X can either equal 4 or x can equal negative 3, and the value of the function would be 2. Graphing rational functions. In any rational function, since it's a fraction with polynomials, an asymptote is a line that the graph approaches. It'll look like a dashed line when you put it on the actual graph. There are different rules in order to get the value of each of these asymptotes. The vertical asymptotes, the lines that are going up or down, will happen when the denominator of your rational function, when that is equal to 0. Because if your denominator is equal to 0, it's undefined, and you can't have a value at that point. Horizontal asymptotes are going to look at the degree of the numerator and denominator and compare them. If the degree on the numerator we call n, and the degree of the denominator we call d, if the degree on the numerator is less than the degree of the denominator, then the horizontal asymptote is automatically y equals 0. Looks like where it's on the x-axis. If the numerator and denominator's degrees are equal, the horizontal asymptote is y equals the leading coefficients. And we'll talk about that when we get to a problem. If the last situation would be if the numerator's degree is greater than the denominator's degree. In this case, there would be no horizontal asymptote. It just wouldn't go toward any horizontal line. The asymptote would be oblique, and what that means is it would be on a diagonal. It wouldn't be horizontal or vertical, and it would be a problem that you'd have to solve by dividing your rational function and finding its quotient, and that would be the equation of the asymptote. We won't do that in this section. That'll be later, but at least you know there is a possibility that you do have another type of asymptote. We just won't be finding it.